Right. Going forward, we're going to talk about relational predicates, and that opens this gigantic can of worms with a lot of things to go over. So I'm going to break these down into much smaller videos since I think these concepts can be difficult to grasp at first. So what's the point in throwing everything at you at once when we can just take everything nice, slow, and simple? So we're going to start by talking about what a relational predicate is, and then as you could see at the bottom of your screen, we'll talk about overlapping quantifiers. So we've dealt with predicate logic, simple statement translations like Chris is tall, right? Where our subject was a lowercase letter and then the description of that subject was a capital letter. So we would translate a statement like Chris is tall to TC, right? That's what we've been doing. But now, what if I want to talk about relations between or among many subjects? For example, if I wanted to say, Chris is taller than Gabe, I don't have a way for us to translate that until now. See, what we do is we would translate this as we have been. So Chris is tall, right? But now we have Chris is taller than Gabe. So what we do is we add an additional lowercase letter, G for Gabe, and this would be our translation, our description, or our relation, I guess. Taller is the capital letter. The first subject will be the first lowercase letter that appears, so Chris. And then the second subject, the one that's being compared to, will be the second lowercase letter that appears, so G for Gabe. Similarly, John owns the bike. O is our capital letter, and then we'll put a lowercase j, not a capital J. J and then B for John owns the bike. Frank hates Matt. Say H for hates. Then Frank and Matt. X, and now I said among earlier, which indicates more than two subjects. We're not going to deal with that, but I figured I might as well just show it. So if we have X's between Y and Z, so now we have three different things. Between X and then Y, Z. So just the order that the subjects appear in. So I don't think that's too difficult. This will be our new notation. Now what I want to talk about are overlapping quantifiers. So if I have statements that can be quantified, sometimes we'll have overlapping quantifiers, and we need to discuss those kinds of translations and the differences between them. So if I say Johnny loves everything and Johnny enjoys everything, everything that's going to be a universally quantified statement, right? So if we have a universal quantifier, we'll say for all x, Johnny enjoys everything. So we'll say enjoys Johnny x. There we go. For all x, Johnny will enjoy x. Johnny enjoys something means that there exists an x such that Johnny will enjoy it. For everyone loves everyone, now we have overlapping quantifiers. We are going to have to use two quantifiers, so we use x and y. And for everyone loves everyone, this essentially just means for all x, for all y, x loves y. If you have a statement like someone loves someone, those are existentially quantified statements. So we'll have a there exists an x, there exists a y, such that x loves y. And then for everyone loves someone, everyone is universally quantified, someone is existentially quantified. So we'll say for all x, there exists a y such that everyone loves someone, so we'll say x loves y. Now, one thing I would like for you to notice is that when we have two of the same kind of quantifier, so with everyone loves everyone, we have two universally quantified, two universal quantifiers, right? The order in which we wrote those universal quantifiers didn't matter. It doesn't matter if I wrote for all x for all y or for all y for all x. Likewise, it doesn't matter if I wrote lxy or lyx. It all means the same thing, and I hope that's kind of clear. However, when we have two different quantifiers, so like with everyone loves someone, we have a universal and an existential quantifier, that order matters. So let's see why. So our example for everyone loves someone means that for all x, there exists a y such that x loves y, which means you can choose any person on this planet, right? And we'll just say that x and y are always people. You could choose any person on this planet, right? For any of those X, I can find a Y. I can find another person out there that X loves. Now, what if I had the opposite statement? What if I had there exists an X for all Y such that LXY? What this is telling us is that there exists one person who loves everybody. So that is a completely different statement than everybody loves someone. I think it's a lot easier to find everyone who loves somebody than it is to find someone who loves everybody. So we've seen that the order of these overlapping quantifiers matters, and likewise, the order in which we write our subjects, so LXY or LYX, is going to matter. So that's why I have all these examples written on the right side of our screen. We're going to see how this translates. So L in this case will stand for loves, and we will restrict X and Y to just people in the universe. That's not how we've been doing things. We're just doing this for the sake of an example. In the next video, when we start doing translations, you'll see that saying that everybody loves somebody is a much more complicated statement than just for all X, there exists a Y, LXY. Anyway, let's just focus on what we're doing now. There exists an X for all Y such that LXY. What does that mean? So that means there is someone, that's someone being X, there is someone who loves everyone. Because I'm saying there exists an X, so there's somebody who loves everyone. There exists an X for all Y, such that X loves Y. Now in our second statement, swap the letters Y and X. How is this going to change our translation? Well, this is saying that there is someone that everyone loves. That everyone loves. Because there exists an X for all Y, such that Y loves X. So there's somebody that everyone loves. Now we're going to flip our quantifiers, so we're going to go universal first and then existential. So for all X, there exists a Y such that X loves Y. So that means that everybody is going to love someone. And we've done that already. That was our example. So that means everyone loves someone. So hopefully I don't need to explain that again. And now for all X, there exists a Y that Y loves X. So that's going to mean that everyone is loved by someone, or you could say someone loves everyone. Everyone is loved. Yeah, actually I like someone loves everyone better. Everyone for all X, there exists a Y. No, yeah, no. You would say everyone is loved by somebody. Everyone is loved by someone. And again, this comes from the literal translation of for all X, there exists a Y, such that Y loves X. So we're saying everyone is loved by someone. So I hope all these little translations made sense. If they do not make sense to you yet, if this is all too much information for you, go through the video again. Take some time to digest and process the information, because what we are going to get into next time and continue to do will be extremely complicated if you do not understand these basics right now. But anyway, if you made it to the end of this video, thank you for watching. I really appreciate it, and I hope you learned something.